Artist's depiction of OSIRIS-REx flying past Earth. Photo credit NASA.gov. After almost a year of orbiting the Sun, on September 22, NASA's OSIRIS-REx Origin Spectral Interpretation Resource Identification Security Goleth Explorer made its closest flyby of Earth. Moving at speeds of about 19,000 miles per hour, the spacecraft passed within 11,000 miles of the planet's surface just south of Chile, before zooming over Antarctica. The carefully orchestrated encounter was designed to take advantage of the Earth's gravity to help launch OSIRIS-REx to a tiny asteroid named Bennu. Referred to as the slingshot effect, or gravity assist, the ingenious method helps propel spacecrafts to faraway distances without expending precious fuel. Measuring just about 500 meters (1,640 feet) in diameter, Bennu is the smallest object NASA has ever attempted to orbit. Peter Antrejan, the navigation team chief from Kinet Aerospace responsible for getting the space probe to its destination, says, "The asteroid's small size and low gravity makes OSIRIS-REx the most challenging mission that I have worked on." However, of the 7,000 near-Earth asteroids, Bennu was one of only 5 that met the required criteria. It was close enough to Earth, large enough for a spacecraft to make contact and, most importantly, had a primitive composition, meaning it contains the organic molecules believed to be the building blocks of life on Earth. How Bennu was selected. Image credit NASA.gov. The $800 million mission began in September 2016 when the spacecraft was launched to seek out Earth-Trojan asteroids, rocks that have stable positions in the Earth's orbit around the Sun. Though it was unable to find any, the time in space allowed NASA to tweak OSIRIS-REx's path to ensure it would reach its final destination. If all goes according to plan, the spacecraft will enter Bennu's orbit in August 2018 and start surveying the asteroid as well as mapping out potential sampling sites. In July 2020, OSIRIS-REx will make contact with a space rock for about 5 seconds and release a burst of nitrogen gas to stir up the surface rocks and soil, which will be instantly added up by a sampler head attached to the space probe's robotic arm. In March of 2021, OSIRIS-REx and its precious cargo will begin the journey home, with an expected arrival on Earth by September 2023. An image of Earth captured by OSIRIS-REx camera during the flyby. Photo credit NASA.gov. Edward Beshaw of the University of Arizona, deputy principal investigator for the mission, says, "By bringing this material back to Earth, we can do a far more thorough analysis than we can with instruments on a spacecraft, because of practical limits on the size, mass, and energy consumption of what can be flown." The expert adds, "We will also set aside returned materials for future generations to study with instruments and capabilities we can't even imagine now." While this may seem like a lot of money and effort to collect a tiny rock sample, it may be well worth it. That's because scientists believe that asteroids like Bennu harbor organic matter from the young solar system. Made of molecules containing carbon and hydrogen atoms, they are the key to uncovering how life first formed and also for finding extraterrestrial life. Resources NASA.gov, skyandtelescope.com, space.com